Welcome to another session of Everyday Mathematics here at Everyday Mathematics. As we always say, we do enjoy solving the harder problems, but also we see and appreciate the beauty in the simpler problems. Now, today we are still at the MIT 2022 Integration B, and we moved forward to the quarterfinals, and we're picking a problem from the polynomial series, which is problem number 3 from quarterfinal number 1. So the problem that we will be dealing with today is the integral of x to the power 1010 over into bracket 1 plus x all into power 2022. And that is from x equals to 0 to x equals to infinity. So very looks complicated because of the bigger numbers, but as we'll see, it's a much simpler problem. Now, before I jump into the solution, I'd like to just shout out to our subscribers. Thank you so much for the big support that you continue to show us. We do appreciate that support, and we don't take it for granted. And that's why we come here every day, because I would like to keep that trust. For our first-time visitors, we'd like to encourage you to subscribe. In short, what we do here at Everyday Mathematics is to go out there, look for the problems that seem hard, and then we come and share with you the solutions. For our second, third, fourth, fifth time visitors who haven't gotten the motivation to subscribe to our channel, we'll just encourage you to please pause the video for a second and subscribe to our channel. This support will really go a long way in giving us that extra visibility that we need. So going forward into the solution, this problem is interesting. As we can see, the x to the power 1010 can be kept like that, and then we can re-express what is in the denominator as the derivative of negative 1 over 2021 times 1 over 1 plus x to the power 2021. Because if you differentiate this, you get what is in the denominator. In other words, it will be 1 over 1 plus x to the power 2022. So if we consider this initial part as u, and then this entire second part as dv, then du is just simply 1010 times x to the power 1009. And then v is simply what is in the bracket here, which is negative 1 over 2021 times 1 over 1 plus x to the power 2021. And then now if we use integration by parts, where if you have a product of u and the dv, then the solution is uv minus the integral of v and du. So that's the solution for integrating the product of u and dv. So we now know what our u is and what our dv is, and then we now can plug in the u, which is obviously x to the power 1010 times the v, which is negative 1 over 2021 over 1 over 1 plus x to the power 2021. And then since this is a negative, when we apply this negative, this becomes a positive. And so since we're differentiating u, so du now is 1010 times x to the power 1009. And then since our v has this denominator 2021, and then also 1 plus x to the power 2021. So we have this derivative, which is pretty much similar to what we have here. So what this is telling us is we do have a recursive problem here. So when we continue, now we have this initial part. This initial part here tends to 0. Why? Because the limit of this as x tends to infinity, as you can see, both the numerator and denominator tends to infinity. So if you apply L'Hopital's rule and you keep differentiating, at some point, the numerator becomes a constant and the denominator still possesses the x component. And so at that point, the upper limit tends to 0, but the lower limit at the very first instance also tends to 0. So this initial part would always tend to 0. And so what we're left here is that the integral of the product of these two functions is 1010 over 2021 times a very similar integral with the powers of both the denominator and the numerator reduced by 1. So, and then if we continue applying the same solution to what we have here, we see that now we have this extra constant here, while we know that this would tend to 0. So now we have a product of 1010 over 2021 times 1009 over 2020 times the integral very similar to this, but now with the powers of both the denominator and numerator reduced by 1. So that continues on and on until we reach a point where we have 1 here in the numerator. And when there is 1 here, it means that we have x to the power, we have x to the power 1 minus 1, which is obviously x to the power 0, because when you see here, if we have 1009, then here it's 1008. So it's the power is 1 less than this constant. So here, the power of x would be 1 less than this constant, so this becomes 1. So we have now the final integral here, which can easily be integrated. And as we see here, this is the same as negative 1 over 1011 times 1 over 1 plus x to the power 1011. Applying the limits, this at the upper limit would tend to 0. At the lower limit would tend to 1, because when 0 enters here, this becomes 1, 1 to the power 1011. This just becomes 1, because now the lower limit is what remains, this negative sign disappears. And so essentially you have in the numerator a product from 1010 to 1 by 2, from 1010 to 1009 all the way to 1. In the denominator, we have a product from 2021 to 1011. So as you continue, we have a way of expressing a product of numbers all the way down to 1. And that is, we'll say that the numerator is 1010 factorial. And then in the denominator, we have 2021 just to 1011. We can multiply both sides, both the numerator and denominator, by the factorial of 1010. And so what that means is that it completes the multiplication, the factorial of 2021 in the denominator. So in the numerator, however, we have a square of 10,010, but in the denominator, we have the factorial of 2021. So this is the answer to that problem. It's not a very complicated problem, but with care and precision, one should be able to get this very interesting answer. So it was an absolute pleasure hanging out with you. I hope you enjoyed the solution. If you have any question, if you have any shout out, please leave a comment below, and we'll be able to get back to you in time. Thank you so much. Until next time,